Welcome back, students. This is Module 2.4.2, History of Photosynthesis. You will recall that last module we introduced you to photosynthesis. We ended with this pictorial summary of the process. This little picture shows sun shining on a green plant. I'm somewhat reluctant to call this next module History of Photosynthesis because we don't really cover all of the history. We just cover a couple of historical episodes, and so think of it in that light. The first episode that we're going to discuss is that of Jan Baptista van Helmont. He was a Belgian doctor. He was very bright, and like many intelligent people, and virtually all people, he believed that his opinions were correct. If I have an opinion and I think it's wrong, typically I change it to where I think that I am holding on to the correct opinion. In any case, he got into trouble with some people who had political power at that time, and this is a branch of the Catholic Church, a monastic order called the Jesuits. They're renowned as scholars, and at that time, they didn't much like von Helmont's kind of arrogant attitude. And because they had political power, they had him imprisoned. And later he was released. And von Helmont was aware that the Jesuits supported Aristotle's historical view that plants derive the material for growth from the soil. I mean, it was evident by looking. You could see these big roots going down into the soil and plants getting bigger. So it seemed evident to the Jesuits that the plants were sucking materials up out of the soil for growth. And this was the view that they held. Von Helmont designed an experiment to test this belief. This was kind of his revenge by science. He took a willow branch that weighed exactly 5 pounds. He trimmed it till it weighed 5 pounds. And he placed it in 200 pounds of soil. And this soil was not just 200 pounds. He oven dried it, and he carefully put a metal plate with a hole over the pot. And through the hole, he stuck the willow branch. And you may or may not know that willow trees are capable of what is called vegetative propagation. This is a form of asexual reproduction in which a single willow branch can give rise to a whole tree. And he watered the tree, grew it for 5 years, and at the end of that time, he weighed both the willow tree and the soil to test the hypothesis that plants gain the material for growth from the soil. And by the way, I want to assign all of you homework. I want you to look at the big willow tree by the pond. And it was planted by a single willow branch from the San Pedro River, stuck there by one of the custodians around 1995. You can see how large that tree is. It weighs hundreds and hundreds of pounds. Well, in the case of von Helmont, by the way, he's seen by history as bridging the pseudoscientific endeavor of alchemy, the effort to turn lead into gold, and chemistry. So he was doing all sorts of chemical experiments as well. So he was very enveloped in science. But here we can see a depiction of his pot with a 5-pound willow branch in it. And 5 years later, the tree grew much, much larger. The soil only lost 2 ounces in that time, and the willow gained 164 pounds. So again, to summarize that, the willow had gone from 5 pounds to 169 pounds. The soil had gone from 200 pounds to 199 pounds, 14 ounces, losing 2 ounces. And so von Helmont concluded the material for growth does not come from the soil, but from water. Now, the reason he made this conclusion, which in fact, the first part of it is correct. If he would have only corrected that the material for the growth of plants does not come from soil, he would have been correct. But he went too far and said that it does come from water. Having watered a plant for 5 years, and water is fairly heavy, weighing over 8 pounds per gallon, and I've watered plants out in the wild, out in the field. It's very difficult, and so I can understand why von Helmont might have come to this incorrect conclusion. He over-concluded from a good experiment, if you will. And we know now, with modern science and numerous subsequent experiments on the topic, that the material for growth from plants primarily is carbon. The carbon in carbon in glucose, for example, and that comes from carbon dioxide, from the air. And this is an idea that science had not arrived at yet, that the atmosphere had air that had mass. And so it was just a little too early for Van Helmont to reach the right conclusion. Let's look at an additional historical episode. This gentleman that you see in the upper right of your slide is Joseph Priestley. He was an English clergyman back in the late 1700s. And at that time, it was very common for clergymen to do all sorts of scientific experiments. And he did the most famous of scientific experiments. He lit a candle, and placed it under a jar, and sure enough, it goes out, okay? And he concluded somehow that a candle damages the air, it harms the air, because if he subsequently tried to place a lit candle in that same jar, it would not support the burning of a candle. And yet if you took a fresh jar of air, it would support the burning of a candle that was placed in it. And so he's saying somehow when a candle is placed in there, it burns and it harms the air. Kind of an interesting hypothesis. Later, he continued along this line of experimentation, and he found that plants could restore the air, and that the candle will burn after a plant is in a jar for a while, after it burned initially, and damage the air. Putting a plant into that same jar would restore the air so that a candle would subsequently burn in that same jar, which had held what he called damaged air. He also extended his experimentation beyond candles to mice, and he found that a mouse, like a candle, was found to harm the air, and he found many parallels between what happened with a mouse and a candle, although it did take longer for the effects of the mouse to be observable. He'd place the mouse in a jar, and the mouse would die. If you put a plant in that jar, it could restore that air so a mouse could live. And the timing of this varied, and it was kind of interesting. All these experiments helped Joseph Priestley to help to discover oxygen. He is not directly credited with that discovery. I think it's Lavoisier, the French chemist, who is credited with that. But his experimentation helped us to move toward the discovery of oxygen. And here's some depictions of his experiments. See the mouse in there with the plant, doing just great. On the other hand, you put a mouse in the bell jar without a plant, and bad news. R.I.P., rest in peace. Oh, and there's a little Lily. Too late, though, at the funeral, and not in time to save our little mouse. Anyway, these are a couple of historical episodes. We will probably present at least one more in a later module, but that will conclude this module.